Let's go to page 111 and start with number 51. Okay, you have sine of theta equal to 1 over 2, and you want to find the least positive angle theta in degree and radian. Okay, so first what you need to do is sine is 1 over 2. Okay, so it's vertical. So vertical is 1, so it's short. So 1 is short. Square root of 3 is long. So you get this picture over here. So it'd be 1 over 2. Okay, so you get two possibilities. Now since you're looking for the least positive angle, so this will give you a lower angle, so you don't worry about that one. Okay, and so this will be square root of 3. Okay, and so from this picture you can see that this is a 30 degrees. Right? So from here you can see that theta equal to 30 degrees. Okay, and also you want to put in radian. Okay, so equal to that, and also radian would be pi over 6. Okay, so that's it for number 51. Okay, so that's answer for A, answer for B. Okay, number 53, cosine theta equal to negative 1 over 2. Okay, so cosine is a horizontal, so horizontal is negative 1 over 2. So you got these two possibilities. Okay, but again, you're looking for the least positive, so you don't worry about this one here, because this would be smaller than this, right? So you don't have to worry about that one. And then you put in your numbers. So this is your 60, 30, 60 spatial triangle. Okay. Okay. So, but remember, you're looking for theta. This is alpha. Okay. So in this case, alpha is equal to 60 degrees. But you're looking for theta. Theta is always start from here and go over here. Okay. Well, this is 180, right? So you see, here's 180, and if you go backwards 60, this will give you 120. Okay. So in this case, theta equal to 120 degrees. Okay. And if you convert this into radian, this would be 2 pi over 3. Okay. Or you can just count, right? So again, this is 1 pi over 3, 2 pi over 3. Now, if you're not comfortable with radian, what you do is get the degrees and then convert, right? Convert that into radian afterward. Okay, number 55. Tangent theta equal to negative square root of 3. Now, since this is a slope, so what you want to do, you want to put over 1 as a fraction. Okay, so slope, so this is the y over the x. So y is negative 3. And horizontal is 1. So horizontal is 1, positive, right? So it's 1. So this is short, and this is longer, so you just draw it longer than that. So again, short. So whatever length you draw, you just make this longer than that. Okay. So that's your 1, negative square root of 3, and so this will be a 2. Okay? Okay, so this is your 60 degrees over here. Okay. Now to get theta, you want to go this way. So this is 360. You start with the angle that you know and you go backward. Okay, so 360 you go backward by 60. This would be a 300 degrees. Okay, remember you're going to get the least positive, right? Okay, so you want to get a least positive angle. So in this case, theta equal to 300 degrees. Okay, and if you're going to convert, if you don't know mentally, what you do is you do this, right? You times it by pi over 180 degrees. Okay, and so you get rid of a 0, and you divide by 6, you get 3. Divide by 6, you get 5. So you get 5 pi over 3. Okay. Oh, and this one here. Next one, number 57. So you got sine of x equal to 0.9525. Okay, so A, sine of x plus 2 pi will equal to what? Well, if you understand what this means, is that x is an angle. So you have So that's your x over here. So when you have x plus 2 pi, basically means you go around the circle one time. So you end up with exactly the same spot. So since when you plus 2 pi, you go around the circle one time. So you're going to end up at the same spot. Therefore, you're going to get same triangle. Therefore, you're going to get same value. Okay? And that's it. Okay? And B, you got sine of x minus 2 pi. Okay, so x minus 2 pi means you're going clockwise. Okay, so you start over here. So your minus 2 pi, so you go backward this way. Again, you end up at the same spot. So therefore, this is going to be the same answer. Okay, so basically just go around the circle. Okay, now C, sine of x plus 10 pi. Now x plus 10 pi is a 5 circle. Okay, so this one means you go around the circle 5 times. So you go 1, that's 2 pi, one more time, 4 pi, 6 pi, 8 pi, 10 pi. Okay, so again, when you plus 10 pi means go around the circle 5 times, so you can end up at exactly same spot. Therefore, you're going to get same answer. Okay. And for part D, sine of x minus 6 pi. Now 6 pi is 3 circles. So in this case means you go clockwise 3 circles. So start from here, so be minus 2 pi, minus 4 pi, okay, and then minus 6 pi. So again, you end up at the same spot, so you're going to get same answer. Okay, 59. You want to evaluate tangent of x, and you want to evaluate sine x and cosine x. So A, when x equal to 1, so you're going to get your calculator and make sure it's in the radian mode, because this is radian, right? And you take the tangent of that. And this one to 2 significant digits. So the answer would be, so tangent of 1 will equal to 1.6. Okay? And then from here, you're just going to do the same thing. So sine 1 radian over cosine 1 radian equal to, so 1 radian sine divided by 1 radian cosine equal, again, it's going to be 1.6. Okay? So you can see that this is the identity. So it's tangent equal to sine over cosine. Okay, so they are equal. Okay, so this is your identity. And you do the same thing for B. Okay, so tangent of 5.3 radian equal to, so 5.3 radian tangent of that equal negative 1.5, and then you have the sine of 5.3 over cosine of 5.3. As you can see, equal to negative 1.5, right? So again, this is just to prove this identity, okay? And let's go to C. Tangent of negative 2.376. Again, make sure you're in the radian mode. Okay, so 2.376 negative, take the tangent of that, so it's equal to 0.96. Okay, and then you do the same thing with the sine. So sine of negative 2.376 over cosine of negative 2.376. Okay, so get your calculator. So negative, okay, this one you have to, so 2.376 negative sine divided by 2.376 negative 2.376 negative cosine equal. So again, you get 0.96. Okay, So this kind of show you the identities. They are equals. Tangent equal to sine over cosine. Okay. Okay, next one, number 61. So you want to evaluate sine of negative x and negative sine of x. Okay, and for A, so you're going to have a sine of negative 3 radian equal, and you're going to have negative sine of 3 radian equal. Okay, so you can make sure it's on radian mode. So 3 negative, you push sine, and so 2 significant digit will give you negative 0.14. Okay, this one over here. So 3 sine of that and times by negative, you get negative 0.14. So you can see that they are the same, they are equal. Okay, so this equal to that. So there's another identity to do. Okay. And again, just to make sure, let's do the B. So you got sine of negative x will become positive. So you get negative 12.8. Okay, so that's what you get. Okay, so this will equal to, so it become positive. So you got 12.8 positive. Take the sine of that. You get 0.23. And over here you got negative sine of negative 12.8. Okay, so 12.8 negative. Take the sine of that and take the negative of that. You get 0.23. So again, you can see they're equal, right? Okay, so do C. So you got sine of negative 407. Then you got negative sine of 407. Okay. So 407 negative, take the sine of that, you get 0.99. Okay, 2 significant digits, you run out to 2 significant digits. Over here, you get 407 sine of that, take the negative, again you get 0.99. Okay, so again they're equal. Okay. Okay, next one. Okay, evaluate sine square x plus cosine square x. Okay, so x equal to 1 radian, so you're going to get sine 1 square. Remember, this square means you square that, right? Okay, plus cosine of 1 radian square. So basically what you have, okay? So again, this square is, you evaluate each one and you square that, okay? So you got 1 radian, take the sine, okay, and then you square that, plus 1 radian, cosine of that, then you square that, equal 1, okay? So again, that's your identity. Basically, you got a squared plus b squared equal to c squared, and c squared would be the hypotenuse. And this is for unit circle, so answer would be 1. Okay, so that's your identity. This is going to always equal to 1. Okay, and if you don't believe that, you can try different numbers. Okay, so you have sine of negative 8.6 squared plus cosine of negative 8.6 squared equal to, okay, so 8.6 negative radian sine of that, and you square that, plus 8.6 negative cosine of that, square that, push equal, you get 1. Okay, and then do the C. So again, you got sine of 260. So these are just random numbers. Okay, just to show you that it works for any numbers. Okay, so again, you just choose any random number, it's going to work. Okay, so 263 radian, you take the sine of that, and you square that, plus 263 radian cosine of that, square that, push equal, you get 1. Okay, so it is always work out. Okay, so that's your identity. Okay, next one, number 65. Okay, so this one you want to simplify the identity. So you got sine x cosecant x. So to simplify, you want to convert everything into primary functions. So this is equal to sine of x. Cosecant is 1 over sine. Okay? Right, cosecant is 1 over sine, and so this cancel out. So answer equal to 1. Okay, next one. We got cotangent of x times secant of x. So cotangent, again, remember, to simplify, you convert everything into sine and cosine. Okay, so that's an easy thing to do. So cosine is equal to cotangent equal to cosine over sine. Okay, and secant is 1 over cosine. So cosine cancel. So you end up with 1 over sine. 1 over sine would be cosecant. Okay. Okay, number 69. Okay, you got sine x over 1 minus cosine square x. Now this one, you have to, whenever you have a square, you have to think about your Pythagorean identity. Okay, remember you got sine square x plus cosine square x equal to 1, right? So if you were to minus, move this over, so you got sine square x equal to 1 minus cosine square x. Right? You just minus the cosine square from both sides. So that this will cancel out. So you get that. Okay? So 1 minus cosine square is equal to sine square. So this is equal to sine x over sine x squared. So when you cancel, this will become sine x. Okay? And 1 over sine x is cosecant x. Okay? Okay. Oh, this is the 69. Sorry about that. 69. Okay, 71. Okay, you got cotangent of negative x, and you got sine of negative x. Okay, so first let's convert into sine and cosine. So cotangent is equal to cosine over sine. Okay, so this is equal to this is equal to that. And notice this will cancel out. So you got end up with a cosine of negative x. But cosine of negative x is equal to cosine of x. Because, see, if you look at the angle, so here's your x, right? So cosine of x is over here. And then if you go negative x over here, if you go this way, okay, then again, horizontally the same. So they are equal. So this will equal to cosine of x. So cosine negative x equal to cosine of x.